Year 6, Lesson 5, Extensive Exercise, Question 3. A puzzle starts with 9 numbers placed in a grid, as shown. In each move, you're allowed to swap any 2 numbers, so that the total of the numbers in each row becomes a multiple of 4. What is the smallest number of moves needed? So, if we look at the remainder of each number when divided by 4, it will help us to understand the remainder of each row. So, I'm just going to fill out the table. For example, 29, when divided by 4, has a remainder of 1. And so on. We have 2, 0, then 2, 3, 1, then 1, 0, 2. Just seeing for each one how much bigger it is than a multiple of 4. So at the moment we have a remainder of 3 in the first row, a remainder of 6 in the second row, which of course would really become a remainder of 2, and a remainder of 3 in the third row. So that's using the additive property of remainders. As we know, when you add numbers together, we can add their remainders together too. So, how can we form 3 rows that are all multiples of 4? That means their remainder needs to be 0, 4, 8, or whatever we can find. Now, if you add together all of the remainders in this grid, we get a total remainder of 12, okay? Which means, is it possible that I can find 3 zeros? Well, that's certainly impossible because there are not 3 zeros. So therefore, I must have 3 rows adding up to 4, okay? We also can see that it's impossible to find a remainder of 8 using the biggest numbers, 3, 2, and 2. So I'm going to have to change all 3 rows. I'm going to have to change all 3 rows in some way. So we can start off with this big one in the middle, which has a remainder of 6. So how can I change this remainder? Let's see if we could do it in one move. So perhaps I could swap, I need to reduce that total remainder by 2. So I'm going to swap that number in the middle to reduce that remainder by 2. So now, I'll do it in a different colour so you can see second step. Our remainder in the first row is going to be 2 higher, so that's going to be 5. Then our remainder in the second row is 2 less, which is going to be 4, and our remainder in the third row is unchanged. So we've still got to make another move. Let me leave a little note here to see that's a 3 and that's a 1 now. So I need to still change row 1 and row 3. Row 2 is fine. So 3, 2, 0, I need to try and reduce that by 1, and 1, 0, 2, I need to increase that by 1. So therefore we could perhaps swap a 2 for a 1. So using my green pen, I'm swapping the number in the middle, 18, that has a remainder of 2, with a number that has a remainder of 1. And now we get a remainder of 3 plus 1 plus 0 in the top row, which is 4. The second row is still a remainder of 4. And the third row is now 2 plus 0 plus 2, which has a remainder of 4. So it was impossible in one move, but it is certainly possible in 2 moves. So our answer is going to be 2 moves. And that's not the only way that we can swap 2 numbers. There are different ways to do it, but we saw that it was certainly impossible within one. Okay?